Hi, everyone. Thanks for attending my talk. My name is Andrew Anderson. I'll be presenting our work, Mental Models of Mere Mortals with Explanations of Reinforcement Learning. So, in the title, I mentioned these mere mortals. It's fair enough to ask, what do I mean by that? I'd like to introduce you to Alex, who's a domain expert. So, they're capable of doing things like flying planes, calculating taxes. In our specific case, they're real time strategy game players. It's important to note that they are not AI experts, so they don't have any formal knowledge in AI or how it makes its decisions, which got us wondering which of two explanation types might work for such people. Would it be a saliency explanation, so where the AI is looking when it's making its decisions, or a reward explanation, some calculated future score for an action it takes just now? For those not familiar with real time strategy games, this is StarCraft 2. It's a very busy environment and there's a lot of opportunities to miss information. We wanted to make sure that our participants didn't miss any information, so we designed our own game. In this game, the AI makes decisions, those diamonds along the bottom, and for those decisions, the AI is controlling this kite shaped tank in the center of the map, and it has to decide which of four objects or four quadrants it wants to attack. So in this case, would it attack its allied objects, those white objects on the right, or its enemies, those objects on the left? So once it goes through and makes that decision, it has to destroy that object or be destroyed. And if it destroys the object, it continues to make decisions until it's destroyed. So what about the treatments for our study? We had four treatments in an ablation style study where the control just had access to the game map. And the saliency treatment had access to both the game map and the saliency maps, which you can see in the middle. The rewards treatment had access to the game map and the reward bars, which you can see on the right. And for the everything treatment, we gave them the game map and both explanation types. Our research questions were as follows. RQ describe which treatment is better and how it enabling people to describe how the system works. So they're forming a rule book in their head in the form of a mental model. RQ predict, it does another measurement of a mental model. Which treatment is better and how it enabling people to predict what the system will do. And then when they're predicting, how are they doing so? What information about the agent or AI do people draw upon to make their prediction? For the purpose of this talk, I'll be dropping RQ describe. So let's get started with RQ predict. At each decision, our participants would see the map without any explanation, and they would have to select the object that they think the AI would attack. If they didn't get it correct, we gave them 0 points. And if they did get it correct, we would give them 1 point. So from this graph, all I really want you to see is that there was a lot of variation in people's accuracies across the 14 decision points. So from this, we had to derive patterns such as these 3 decision points, where the control, those green bars on the left, were actually the most accurate compared to any of the other treatments. So why was this? So we started looking at some of their responses, and this is an everything participant, so those blue bars on the right, and they're juggling a lot of information. They're saying, I think it considers this thing, and then it does this thing. So it's a very detailed attempt at understanding what's going on. Whereas the control participant here is using a more intuitive sense. This object has the lowest health of all the enemy objects. This was actually something that some of the participants bemoaned at the end of the task. It was confusing all around to figure out the main factor for movement using the maps and bars in this participant's case. Which is understandable because in the bottom left, that is the interface that they saw. So the next attempt we had to try and gain understanding is from all the decision points, we had to find patterns. In these 3 cases, the presence of the enemy kite-shaped tank is the common theme throughout them. And what we actually saw was that the participants who were who saw reward bars, which are these bars here on the right, they are more accurate at predicting what the agent will do in these three cases than the participants who didn't see reward bars, so these bars here on the left. So let's do a more formal understanding of, how are they making their predictions? So this is an example of the interface that the participants saw before they saw any explanations and they had to predict. So perhaps they're just using information that's currently available. Again, that intuitive sense of what's going on. Perhaps they're bringing in information from prior game states, or maybe they're even trying to predict what the explanation would look like before they see it. So I want to focus on this last point first for predicting the explanation. So this is the number of times that participants used this kind of prediction technique to try and understand what the agent would do. And all I want you to see from this is that the rewards and everything treatments are using it more often than the saliency participants. So this is the box plots of that same information. And what we actually see is that when we run Welch's ANOVA, the p-value is very, very small. So the saliency participants down here are actually using it significantly less than the rewards or the everything to participants. So this is an example of how they're predicting these explanations. This rewards participant is trying to say, okay, this object will provide more damage rewards and most destruction rewards, which were two types of rewards in our domain. But Andrew, I hear you ask, the everything participants saw both explanations, so which are they trying to predict? The truthful answer is some of them did both. That it will look at its friend or enemy, then destroy the one with the highest value. So the look is the saliency and the highest value is the rewards. But 91% of all their predictions were just about the rewards without mentioning saliency maps. So that was interesting. And what about using the current game state? What we actually noticed when we looked at this table was that the rewards and the everything participants were always using the current game state the least of the four treatments. So again, we chart this and we start seeing, okay, this is oddly lower than the others. And when we run the ANOVA, we get a p-value less than 0.05, but it doesn't tell us which one exactly. So once we remove the rewards participants and we run the same test, because the significance disappears, that means that the rewards participants are using the current game state significantly less than the other three treatments. So throughout this paper, here are some of the things we found. We found that counterintuitive situations are in fact difficult, but the participants with reward bars did show some advantages. We found that one size does not fit all participants, which we saw with the larger error bars, or situations, again, that varied behavior. What we did see was that diverse people had diverse reasoning for their predictions, and that warrants further investigation. And we also need an arsenal of empirical methods, both quantitative and qualitative, to hope to explain reinforcement learning to mere mortals. Thank you again for attending my talk. I'll be happy to take your questions.